Oh, hi. Didn't see you there. JJ Katz. I did this thing again. Daniel Millstone.
Oliver Golgoth.
Now we have a mount here which has 4 degrees of freedom. You can see that it can move in the Y direction, the X direction, and it can tip and tilt using the pitch and yaw. Roll is irrelevant, and Z-axial position of the laser doesn't matter too much either. We noticed while we were adjusting that we wanted to add this fine adjustment here, and instead of adjusting in the Y direction using these rough mounts, we wanted to use this fine adjustment so that it wouldn't disturb the rest of the laser. So we left it here up close and adjusted in the X and Y direction, and then we'd move it down here along the rail and ensure that the laser was still aligned using the pitch and yaw.
So now we're testing whether or not the table is aligned with gravity. So what we have is our laser right here, and it's coming through this pentaprism, which gets the laser going at a 90-degree angle down at this water. And since water is level with gravity, when it reflects off of this water, it should go back up through the pentaprism and go back into the laser cavity. And as you can see, if we hit the table, the water moves. And so that dot right there, the one that's moving around a lot, is the one that's reflecting off of the water. And it's not going directly back into the laser cavity, which means it's slightly off from being aligned with gravity. There's 2 dots that move around, and one is from the top reflection off the top of the water before it goes down through the water, and the other one is from going down, hitting off the bottom surface, the bottom interface between the water and the plastic, coming back, refracting through the water, and then up through the pentaprism and back. The one that moves less when we shake the table is the one that hits the bottom with the interface between the plastic, and then comes back up through and refracts through the water. The one that moves more is the one that hits straight off the top of the water.
For this part of the lab, we added in a green laser. This laser had to be mounted in a special mount compared to the other one, but we also included a fine adjustment in both the X and the Y direction like we did last time. We used the same iris with an identical height to ensure that the laser was parallel to the other light. That the green laser was parallel to the red laser. We also ensured that the spacing between these rails is consistent throughout to 0.01 inches.
So to ensure that the green and red lasers line up after passing through the laser pointer, this is what we did. We have this pentaprism here that takes that red laser and puts it at a 90-degree angle into this beam splitter, and then the green laser passes directly through the beam splitter. And so what happens is you get 2 laser beams coming out, and up close we adjusted the pentaprism to make them overlap close up to the beam splitter, to try to make them overlap at that interface. And then far away we adjusted the tip, tilt, and rotation of the actual beam splitter to make them overlap far away. And then we did that over and over again.
So in this part of the lab, we had to align each individual lens, and to do that you place it on a mount, and you align the tip and tilt and the translations across the Y and X directions. When you're translating across the X and Y directions, you can look at the reflections back where the aperture is here, and they'll be moving opposite of each other, so you try to get them to coincide. You then use the tip tilts on the mirror mount to get it so that it's at the center of the cavity. And when you get it aligned, you should be able to see the beam going through the lens and fringes around it, and the beam should be aligned at the center of the fringes. Then the second part of the lab was to put another lens here to make our Galilean telescope. And so once we have this aligned at about 7.5, you should see that the system's even.
So for this part, we took the objective lens and originally marked the laser beam spot with this black pen here. From there, we wanted to overlay the crosshairs using the tip and tilt adjustment on this stage here in the center where the black spot is. From there, we'd also adjust laterally in both the X and Y direction to get this expanded beam also in the center. We would then translate in the Z direction to ensure that nothing changed.
So though it's hard to see in this video, the crosshairs and the dot and the original laser dot without the microscope or the lens are all overlapping. And as I move across the Z axis with the lens, they stay overlapping, which means that they are all aligned.